So our learning objective here is to identify all phases of the cardiac cycle and then understand origin of pressure and describe the relationship between pressure and volume. Okay. We're going to discuss the phases of the cardiac cycle. There are four of them. We're going to talk about the atrial and ventricular pressures. Those pressures are important because they guide the phases of the cardiac cycle. Then we'll talk about the pressure in the aorta. And then we'll talk about how that compares to the ventricular volumes. And lastly, we'll look at the heart sounds for each of those phases. So let's start by describing what the cardiac cycle is. So it's the events that are associated with the movement of blood through the various chambers in a single heartbeat. And we've talked about one heartbeat being the SA node firing one action potential. So what are the events? When you looked at the electrical activity moving through the atria contracting, ventricles contracting, and then up to the Purkinje fibers to the valves, what are the events that actually happen internally with the blood moving through those chambers? So there are two main periods of the cardiac cycle. There's systole, which is ventricular contraction, and then diastole, which is ventricular relaxation. So the phases that we'll talk about today, we're going to look at the perspective of the ventricles. When we say ejection, we're looking at the ventricles. When we say contraction or relaxation, it's all from the perspective of the ventricles. Now, the way that these cycles occur, the way that blood moves through the chambers is due to the pressure gradient. So we mentioned this before that the valves are fibrous structures. They are not contractile structures. They're made of connective tissue, so they don't have the ability to move. What moves them is the difference of pressure between the preceding chamber and the subsequent chamber. So the movement of blood through the chambers happens when the pressure in the atria, for example, is greater than the pressure in the ventricle, and then blood simply moves passively through that AV valve. Similarly, with the semilunar valves, when pressure in the ventricle exceeds that in the artery, then the semilunar valves, aortic and pulmonary, both will open, passively. Now let's think about the first phase of the cardiac cycle. And it actually starts in the middle of ventricular diastole, the middle of when the ventricle is filling or relaxing, and so blood is moving down from the atria. And the GIF that I have here, although it's moving kind of quickly, you can see when the ventricle is open and relaxing, there's blood spilling down from the atria into the ventricle. The middle of that period is what starts phase one, known as ventricular filling. In this instance, blood that has come back to the atria, we call this venous return. Blood that has come back to the atria moves down through the AV valve into the ventricle. And we're looking at both ventricles here. So we're thinking about movement happening across the tricuspid valve as well as across the bicuspid valve. Now, while this is happening, the pulmonary and aortic valves, which are the semilunar valves, those are closed. So we never have a period at any point during the cardiac cycle when all four heart valves are open. Okay, we never have that because that just would not logistically or pressure-wise make sense. So the semilunar valves are closed in this stage, and then there's the passive spilling of blood. So it's kind of just happening passively with that venous return in the chamber. But towards the end of that ventricular filling, the atria actually kind of hone in and squeeze the last bit of that blood down. And we can kind of see that happening as the atria contract towards the end of the ventricular filling. So it's passively at first, but then the atria kind of squeeze to finish up the ventricular filling. Okay. Now, if we think about what's happening in terms of our valves and our pressures and volumes, we're going to talk about this again later, but we want to start to begin connecting this. So AV valves are open, which they have to be because the ventricle is filling. Semilunar valves are closed. The aortic pressure here is down because we're not filling the aorta because the semilunar valves are closed. The ventricular pressure is rising. At the beginning of this is lower, and towards the end of this, it's higher. So as blood moves down into the chamber, the pressure too will begin to rise even before the ventricle can begin contracting. And then, of course, the volume would increase because we're now pouring blood into that ventricle. So volume goes up. And then we'll talk about what the heart sounds look like. But we know that this is equivalent to atrial contraction down here, our P wave from the electrocardiogram. Okay, so P wave is the atrial contraction, and then we have just the beginning of the filling of the ventricle where pressure starts rising. Let's shift to phase two. Phase two is isovolumetric ventricular contraction. And isovolumetric, the term here means that the volume is staying the same. So that means our valves are closed. All four heart valves are closed. So while we said that there's never a period where they're all open, there is a period very briefly when all of them are closed. So here the semilunar valves are still closed. And then because the pressure in the ventricle now has risen due to the blood that has entered the chamber, it's no longer a gradient across the atria and the ventricle. So the valve is going to close as blood stops moving. This is why it's so important to understand the gradients that are created, which allow blood to move, because when those gradients dissipate, then the blood stops moving. So we pour blood down in phase one, and then the pressure in the ventricle is now higher than that in the atria, and so we have a closure of those AV valves. However, the pressure is not high enough for the semilunar valve to open just yet. So while the ventricle is contracting in this phase, we have the start of systole, which is ventricular contraction. We have an increase in pressure, and we're trying to get the pressure high enough here to where it's higher than that in the vessel, in the artery. And now the semilunar valve will open. So it's not high enough in the isovolumetric ventricular contraction, so both the valves are closed. All right, so we want to think about that very brief. It's a shorter phase than we saw for phase one, time-wise, and it is the brief period of contraction to get us to ventricular systole. Okay, if we look at our pressure and volume curves down here, the aortic pressure is still low because the semilunar valve has still not opened. The ventricular pressure has now begun to rise. Notice how it's steeply rising. So this is when the ventricles really contract, okay, which is indicative down here of our QRS complex, right? This is when the ventricles are going to begin contracting. Then we have the atrial pressure still dropping off because now the AV valves are closed. So there's not much change happening in the atrial pressure. And then the volume here is steady. So notice that there's no change in the volume in phase two because none of the valves are open. If none of the valves are open, blood isn't moving anywhere, volume stays the same. Let's look at phase three. Phase three here is ventricular ejection. So now now that the pressure in the ventricle has risen, it's higher than the pressure in the artery, and now we can see passive opening of the semilunar valves. Okay, so here the pressure in the ventricle exceeds the pressure in the arteries, and this is the remainder of ventricular systole, where blood is now being forcefully ejected from the ventricle out into both the pulmonary artery and the aorta. Okay. The ventricular pressure is going to be less than aortic pressure. As the blood starts to move away from the ventricle, that pressure is going to start dropping off as blood is leaving the chamber. Remember, volume creates pressure. So wherever blood is going, pressure is going to rise. So while we have the ventricle contracting, because blood is now leaving the chamber, pressure is going to start falling. And then the semilunar valves will eventually close towards the end of this phase. They're initially open. Okay, so let's look at what this looks like here. So our AV valves are still closed. Our semilunar valves are now open as blood leaves the ventricles. If we look at our pressures, pressure in the aorta now is going to start high, but then drop off as blood moves away and distally out into the circulation. If we look at the ventricular pressure, that's going to be a similar scenario. It's going to start high as the chamber contracts, but then as the valve opens and pressure and blood moves away, pressure will also drop off. Atrial pressure is steady. Again, there's no movement of blood in the atria. AV valves are still closed, and there's no contraction. The pressure here is pretty much the same. And then the volume drops. So because blood is leaving the ventricle, volume steeply drops off, which is matching the pressure change as that volume moves away. And then down here, we can see that this is the beginning of where we have the ventricles contracting, and then the atria are going to start their relaxation. Okay. Lastly, phase 4 is the very last phase of the cardiac cycle. This is isovolumetric ventricular relaxation. So it's the exact reverse of phase 2, which was isovolumetric ventricular contraction. So phase 4 is now all 4 valves are closed again. Because the pressure at the end of phase 3 drops off, we lose our pressure gradient. Okay, so we lose the pressure gradient. We no longer have pressure in the ventricle exceeding pressure in the artery, and so the semilunar valves now close. And what's happening here is the ventricle is relaxing during this phase. So not only is the semilunar valves closed because blood has moved out, but now the pressure starts to go down because the chamber itself has begun to relax. This is the onset of diastole. So this is going to bring us back to the first part of the initial phase where the ventricle is ready to start filling again. So as the ventricle relaxes, pressure decreases. In this instance, both valves are closed and no volume, right? The blood isn't moving or leaving any of the chambers. Hence the term isovolumetric. Remember, if it starts with isovolumetric, all 4 valves have to be closed because the volume is staying the same. Blood is not moving from any of the chambers. Now, if you look at our states of the valves here again, it's a shorter phase, just like we saw with phase 2, a very brief period. All 4 valves are closed. We have pressure in the aorta is going to begin high here as blood is still leaving the aorta, but then eventually that will drop off as blood moves away into the systemic circulation. The pressure in the chamber, ventricular pressure, drops steeply. Again, the chamber is going to begin to relax here. It's going to get ready for filling, and so that pressure will steeply drop off. The volume is the same, just like we saw with phase 2, because none of the valves are open. And then down here, we can begin to see ventricular repolarization. So this is what's happening, getting us ready to start phase 1, which is ventricular filling all over again. In terms of our pressure gradient, because the chamber is relaxing, the pressure is dropping, and when it gets lower than the pressure in the atria, once again, the AV valves will open because we will now have a gradient once again. So we're going to go back to phase 1 at the end of phase 4 here, which is isovolumetric ventricular relaxation. Okay, so this is what our cardiac cycle looks like in terms of our pressure changes, volume changes, and then what the valves are looking like more holistically. So just to kind of recap and review here, we begin in the middle of ventricular filling when AV valves are open. Then we have a brief period when all 4 valves are closed. This is while the ventricle is contracting to get its pressure high enough to open the semilunar valves. In phase 3, we have ventricular ejection or systole when the semilunar valves are open, but the AV valves are closed. And then we have the brief isovolumetric ventricular relaxation. Now the pressure here is falling as the ventricle relaxes and prepares to go back to filling. And then we get into phase 4, or phase 1 again, which is where we have a new ventricular filling, which is a new phase one, right? A new cycle. So this is going to be happening continuously, and this is how blood moves from atria to ventricle, then ventricle out into the arteries. Okay, this is a cyclical process.